Bismillahirrahmanirrahim. Assalamu alaikum. My name is Jamshed Ali and my role ID is 190994. So today I'm gonna introduce you about the introduction and implementation of analog to digital converter known as ADC on ATMEGA 328P and implementing digital thermometer using liquid crystal display LM35 temperature sensor on ATMEGA 328P. So first of all, the objectives we have to keep in mind are to understand the function of ADC microcontroller, learn different mode of operations, integration of LM35 temperature sensor, and implementing DAC and bus interface in Proteus. So the software we are going to use for simulation purpose are the AVR Studio, Proteus. Hardware tools we are going to use are ATMEGA 328P potentiometer, LM35 temperature sensor for implementing digital thermometer, and liquid crystal display for showing any temperature or voltage on our simulation purpose Proteus. So first of all, it is the basic introduction about the ADC. So it converts the analog voltage to 10-bit digital value through successive approximation. The minimum value represents ground and the maximum value represents voltage on the area pin -1 LSB. So AVC on internal 2.6 volt reference voltage may be connected to ARF pin by writing the REFS bits in the ADMUX register. So this is the basic introduction about the ADC. So the ADC has its own interrupt which can be triggered when a conversion completes. A single conversion is started by writing a logical 1 to the ADC start conversion bit ADSC. This bit stays high as long as the conversion is in the progress and will be cleared by hardware when the conversion is completed. If a different data channel is selected when a conversion is in the process, the ADC will finish the current conversion before performing the channel change. So by defaulting, the successive approximation circuitry requires an input clock frequency between 50 kHz to 200 kHz to get maximum resolution. So it contains a prescaler which generates an acceptable ADC clock frequency from any CPU frequency above 100 kHz. So this is the registers involved in ADC, 16 kilobytes, so in system programmable flash memory, and 512 bytes EPROM, 1 KB SRAM, USART, 10-bit ADC. So this is the LM35 temperature sensor we are going to use for implementing our digital thermometer. So LM35 is integrated circuit sensor that can be used to measure temperature with an electrical output proportional to the temperature in degree Celsius. So this is the modes of operation: single conversion mode, free running mode. So single conversion mode, you have to initiate each conversion. When it is done, the result is placed in the ADC data register pair and no new conversion is started. Free running would start the conversion only once and then the ADC automatically would start the following conversion as soon as the previous one is finished. So system clock and clock operations supports internal clock as well as external clock source. System can run on 1 MHz internal clock or external crystal oscillator circuits. These crystal oscillators come in wide range. So this is our lab task in which we have to implement digital thermometer using LCD LM35 temperature sensor on ATMEGA 328P. So first of all, we have to declare the header files avrio.h and the LCD header files which we are creating in our previous labs. So if you want all the code, you can check our previous lab as well. So for displaying or for initiating or for appearing our LCD header files. So this is the stdlby header files for our itoa command which converts our integer to our string. This is our main function. First of all, we have to set the port C as output with the help of direction register by giving maximum value, and we have to set the port F and port B, port F as an input and port B as an output with the help of direction register by giving minimum and maximum values. So first of all, and then we give the command 0x87 to our first register and then 0x30 to our second, and we initialize the character array of 50 integers, and after it we have to call the LCD initial function. With the help of LCD string, we have to display the temperature because we are going to show the temperature on our LCD liquid crystal display. So this is our while loop. It will the bit stays high as long as the conversion is in progress and will be cleared by hardware when the conversion is completed. So if a different data channel such as is selected while a conversion in progress, then ADC will finish the current conversion before performing the channel change by defaulting the successive approximation in circuit requirements. So this is the basic while loop purpose, in which first of all it remains one, and the conversion will take place with the help of this while loop, and then when the previous conversion will stop, then it will clear the hardware, and then next function will perform. So ITA commands is used to convert the integer into a string. So because we have to implement or appear string on our like LCD liquid crystal display, so this ITA command will convert our integer to our string, and then will display on our liquid crystal display LCD. So this is our Proteus simulation before performing on our hardware. So now I'm going to show you the Proteus simulation of our ADC. So this is our Proteus simulation of our ADC. We are implementing a digital thermometer with the help of ADC. As now you can see here, temperature is 0 because I am giving 0 volts. When I am giving 1 2 3 means when we raise 3 volts, then there will be raise in 1 temperature degree Celsius. When we raise 6 volts, then there will be raise of 2 degrees Celsius. As now you can see here, if I am increasing 1 2 3, then temperature will raise by 1. If I am increasing 4 5 6, then temperature goes to 2. So by the difference of 3, the temperature goes to 1. So now you can see here, if I'm raising on 12, the temperature will goes to 5. So this is a basic Proteus implementation of our ADC. So now I am going to move towards the basic hardware implementation of our ADC. Now you can see here, ये हमारा ADC का लैब टास्क है, जिसमें हमने डिफरेंट वोल्टेजेस पे डिफरेंट टेम्परेचर मेजर करना था, LCD पे डिस्प्ले करवाना। ये हमारा बेसिक लैब टास्क ADC performance, digital thermometer performance of our by using ADC liquid crystal display and ATMEGA 328P on our hardware as we performed in our labs. So now you can see here, ये हमारा ADC का लैब टास्क है, जिसमें हमने डिफरेंट वोल्टेजेस पे डिफरेंट टेम्परेचर मेजर करना था, LCD पे डिस्प्ले करवाना था। ठीक है, तो यहाँ पे हमारा 3 के वोल्टेज के रेज से 1 टेम्परेचर सेल्सियस में रेज आ रहे हैं। अब ये हमारा हार्डवेयर पे है, क्योंकि यहाँ पे अभी हमने IC को हीट किया है, तो हमारा यहाँ पे टेम्परेचर 9 डिग्री सेल्सियस शो हो रहा है। जैसे ही IC का टेम्परेचर डाउन होगा, तो यहाँ LCD पे भी टेम्परेचर डाउन होता हुआ नजर आएगा। So this is our basic Proteus and basic hardware implementation of our digital thermometer by using ADC, liquid crystal display, and LM35 temperature sensor. So it concludes that we are using LM35 and how can we implement digital thermometer by using these hardware instruments such as liquid crystal display, temperature sensor. ADC is basically analog to digital converter. So we are also come to know and how our analog value is converted to digital value. So that's all from our side. Jazakallah.